Hi everyone, this is teacher Justina and welcome to my YouTube channel. If you are new, then do not forget to subscribe, like, share, and to comment below. And also do not forget to hit the notification bell for more video updates. Our video for today is all about solving equations which are transformable to quadratic equations. And so far, let us explore. Okay, example number one. Transform the given equation to quadratic equation and solve for the roots of negative 6 over x plus x over 3 is equal to 2. Okay, so as we used to, if we are going to add fractions or if we are going to subtract fractions with different denominators, we simplify the LCD. And since this is an algebraic expression, so one way of transforming this fractional algebraic expression uh, is to find the LCD by just multiplying the denominator. So our denominator is 3 and x. So we will be using this as our LCD, but in some other way. So the LCD will be multiplied to both terms. So the 3x will be multiplied to the left term and the 3x will be multiplied to the right term. So why 3x? Because our denominators are x and 3. So how? We are going to simply 3x divided by x. So again, 3x divided by x, we simply get the quotient of x divided by x. So we simply isolating the x. So the remaining is 3. And the 3 times negative 6 will gives us negative 18. And then at the same time as what we have mentioned that the 3x is a multiplier to all terms both on the left and on the right. So 3x is done multiplying to negative 6 over x. This time 3x times x over 3, or simply 3 and the 3 here will be cancelled. So the remaining is x, and that will be multiplied to x. That is why we have an x squared. So done, and the 3x on the right will be multiplied to 2. Thus we have 6x. And this time we need to transform our expression to the standard form of quadratic equation, in which quadratic term should be written first, followed by the linear, and followed by the constant. So the x squared is positive, while the linear term is on the right. We need to transpose it to the left, so that will become negative 6x. The negative 18 will be rewritten, and this will be equated to 0. And since we need to get the roots, thus the different methods in finding the roots are already discussed on my previous videos. So this time, we prefer to use the completing the square. So in completing the square, we simply have the two terms, the quadratic and the linear. And why uh, the 18 is already on the right side? Because as we complete the square, we simply have the quadratic and the linear term. The constant should be transposed. So our 18 here will be transposed to the right, and it will now become positive 18. And why we have a 9? Because we simply divide the linear term always by a 2, and that answers 3. And then the 3 will be squared, and thus we're able to have a 9 here. Thus what we add on the left to it on the right. So and so far, this is already a perfect square trinomial in which its factors are x minus 3 times x minus 3, and this is 18 plus 9 will gives us 27. And so completing the square method says that we need to since we will be getting the value of our x, so there is a 2 in there, so we need to extract the square root both sides, and we have to also extract the square root of 27, so we have a double sign. Thus These are the two roots. So the 27 can be factored out by 9 times 3. And so far, the negative 3, as to get the first root, the negative 3 will be transposed. It will now be positive. The 9 is a perfect square, thus getting the first root will be using the positive. So the first root is equal to 3 plus the square root of 9 is 3. Then the 3 is not a perfect square, thus the 3 is remain a radicand. And our second root is 3 minus 3 square root of 3. Okay, so another example. So we have to transform this given equation to quadratic. So we have 2x over 3 plus x plus 1 over 4 is equal to 1 over x. So this time I want you to clearly see our denominators. We have already 3, 4, and x. So we have already three denominators. So therefore, okay, so we are rewriting them. As we used to in our first example, our denominators are different, so we need to get the LCD, and one way of getting the LCD is by simply multiplying them if any of, or in other words, the greater denominator, if this is not, if the other denominator cannot divide to that given greater denominator. Thus, one way is to give to find the product, or the products of the denominators will be our LCD. So our LCD will be 3, 4, and x. We will just prefer to write it in this way other than 3 times 4 or writing 12 over 12x. Again, instead of, it could be written as 12 and 12x as our LCD, but I think or writing it in this factored form will be preferable, as to know what particular numbers are cancelled or isolated. So let us now start. The 3, 4, and x are our LCD. So as we have known, our denominator 3, our focus is to isolate them. So therefore, only the 3, okay, only the 3 from our LCD is can be cancelled, or cancelled because it gives us a quotient of 1. So the remaining will be 4 and x. And that 4x will be multiplied to 2x. That is why we have 8x squared. And then next is we are done multiplying the 3, 4, and x to the first term. So our next move is to multiply the 3 times 4 times x to the second term, in which our denominator is x plus 1. Okay, I'm sorry, our numerator rather. So therefore, the 3, 4, and x, only 4 can be cancelled because we have a denominator 4. So the remaining are 3 and x only. And the 3 and x will be multiplied to x plus 1. As you have seen, the x plus 1 is our numerator here. And the 3x is the remaining, or are the remaining terms. 3x is equal to, remember that the x and x here are cancelled because it answers 1. So 3 times 4 times 1 will gives us 12. So to further simplify, we have 8x squared, and then the 3x will be distributed. So 3x squared, and then 3x times 1 we have is 3x. So for this, we need to combine similar terms. The 8x squared and the 3x squared can be combined. It answers 11x squared plus 3x minus 12 is equal to 0. And so far, expression like this, uh, the most applicable formula if we are in doubt if they are factorable or not. We better use the quadratic formula. And using the quadratic formula, of course, we need to get our A, B, and C, the constants in the equation. So therefore, the quadratic formula is given. Thus, we are now ready. Our b itself is 3, positive 3. So the formula is negative b. So we have already a negative 3 plus minus. Our b is 3, so 3 squared minus 4 times 11 as our a, and our c is negative 12. And then 2 times a, which is 11 times 2. Okay, so to further simplify, 3 squared is 9 plus negative 4 times 11 times negative 12 will gives us positive 528 over 22. And so far, okay, we have simplified it in this way. 528 plus 9 is equal to 537 all over 22. And to get the first root, so we have to have the negative 3. Remember that this is separated by a plus and minus. So therefore, we can have our values of x in two terms. So we have negative 3 because the 22 is overall denominator. So negative 3 over 22. And then using the plus first, over 500 square root of 537 over 22, and our second root is negative 3 over 22 minus square root of 537 over 22. Okay, another example. Transform the given to quadratic equation and solve for the roots. We have now 9 over x minus 3 is equal to 2x plus 1. Okay, so for the solution, so far remember that our terms on the right are made up of two terms, 2x plus 1. But remember, they are understood having a denominator of 1, 2x over 1 plus 1 over 1. So therefore, our LCD will be only x minus 3. So again, what we are trying to isolate this time is our denominator x minus 3, and to isolate them is to use that x minus 3 as our LCD. So we are now ready multiplying the x minus 3 to both sides. So therefore, let us now try. So the x minus 3 and the x minus 3 are already cancelled. Then it answers 9. And remember that there's no denominator of 2x plus 1 other than positive 1. So what shall we do? We simply multiply the 2x plus 1 to our LCD, which is x minus 3. And we are to use the FOIL method, the 2x times x. So it will gives us, so 2x times x, we have 2x squared, while 2x times 1, I'm sorry, 2x times x, I know the outer terms, 2x times negative 3, we have negative 6x. And the two inner terms, which is 1 times x, we have x. While the two last terms, 1 times negative 3, we have negative 3. And to further simplify, we need to combine similar terms. So we have 2x squared minus 5x already, because negative 6x plus x, we have negative 5x, and the negative 3, and since we need to equate them to 0, thus the 9 will be transposed to the right side, and it will now become a negative 9. And to combine the negative 3 and negative 9, we have negative 12. So our uh, quadratic equation is now 2x squared minus 5x minus 12. So again, from the given expression, from the given equation, it is now transposed to this quadratic equation. 2x squared minus 5x minus 12 is equal to 0. And to get the roots, we have to again use the quadratic formula. So our a is 2, our b is negative 5, and our c is negative 12. So to substitute it to the formula, our b is negative 5, so negative times negative 5 plus minus, our b is negative 5 squared minus 4 times 2 times negative 12 over 2 times 2. And so far we have a 5 plus minus 25. The 4 times 2 is 8. Times negative 12, we have a positive 96 all over 4. And for that, 25 plus 96 will gives us 121. So we have a 5 plus minus square root of 121 over 4. And for that, we have to get the first root. We will be using the plus first. So 5 plus the square root of 121 is 11 over 4. And remember that 5 plus 1 is equal to 16 over 4. Thus our first term, our first root is equal to 4. While our second root, we have to use the negative. So 5 minus 11 over 4. And the 5 minus 11 will gives us negative 6 over 4. And to simplify further, the reduced term of negative 6 over 4 is equal to negative 3 halves. Okay, so for our last example, transform the given to quadratic equation and solve for the roots of 2x over x plus 1 over x plus 2 is equal to negative 2. Okay, so far, our denominators are x and x plus 2. So, we are going to use the x plus 2 and the x as our LCD or as our multiplier to both sides. So, therefore, this time, we can now uh, see that the x and x here can be cancelled because it gives us a quotient of 1. So, the remaining will be x plus 2. This x plus 2 will be multiplied to 2x, and that will gives us 2x times the binomial x plus 2. Okay, and we're done multiplying that x plus 2 and x to 2x. What shall we do next is to have now the x plus 2 times x, okay, multiplied to x plus 1 over x plus 2. And so far, the x plus 2 is now cancelled because it answers 1. So the remaining is x plus 1, and that will be multiplied to x. Again, the x plus 2 is only cancelled. The remaining is x, and that will be multiplied to x plus 1. So the remaining is x, and that will be multiplied to x plus 1. And again, our LCD, x plus 2 times x, will be multiplied to negative 2. So we have a negative 2. We have the x plus 2 times x. So to further simplify, we are going to apply distributive properties. So 2x times x, we have 2x squared. 2x times 2, we have 4x. While the x times x, we have x squared. And then x times 1 is x is equal to, okay, the negative 2 times x will gives us negative 2x. The negative 2 times 2 will gives us negative 4. And remember, we still have an x in there. So to further simplify the right term, so the x times negative 2x, we have negative 2x squared, while x times negative 4 is negative 4x. So to have uh, to have simplify all the terms on the left and on the right, we gather now the similar terms. Okay, so we have the 2x squared, the x squared, and the 2x squared on the right will be now transposed. Okay, and then we have the 4x here, and then we have here the x, and we have the other 4x on the right, and we transpose it, it will now become a positive 4x. This is equal to 0. And remember that 2x squared plus x squared plus 2x squared will gives us 5x squared. Again, 2x squared plus x squared plus 2x squared, we have 5x squared. And the 4x plus x plus 4x will gives us a 9x. And this will be equal to 0. And again, getting the roots, we can simply apply the factoring method. And the 5x squared plus 9x, the common is x. So that is why 5x squared divided by the common monomial factor, which is x, we have a 5x. And the 9x divided by x, we have a 9, so is equal to 0. So therefore, the first root is this one, x is equal to 0. And our second roots is coming from 5x plus 9 is equal to 0. Thus, Our first root is 0, while our second root will be uh, is equal to negative 9 over 5, because this is simply divide both sides by 5, and that is why we have negative 9 over 5. Okay, guys, I hope you've learned something from my video today. Uh, Transforming equation to quadratic equation, or equations that are transformable to quadratic equation. Uh, if you want to learn more, guys, I want you to please do subscribe and do not forget to hit the notification bell for more video updates. This has been Teacher Justina, and thank you for watching. That in all things, God may be glorified. Goodbye, everyone.